now we're going to talk about the conjugate. So for these first three problems, we're just going to find the conjugate of these complex numbers we see here. So the conjugate is defined as the opposite sign of the imaginary part. So if I look at the imaginary part here is -2. And the imaginary part of the number is -2i. So if I'm going to find the conjugate of it, that's the opposite sign of the imaginary part. So this is actually going to be 3 plus 2i. That's what the conjugate would be. So simply speaking, that's what it is. It's the opposite sign of the imaginary part. So this only has an imaginary part, this second one here. So this is going to be -4i because it's the opposite sign of the imaginary part. So now part C here, the conjugate of this is actually just 6. Because the imaginary part, for this one, I can think of it as plus 0i. And it's neither negative or positive. So I don't have an imaginary part, so I don't have to worry about it. So it's just 6. So there's our three answers for the conjugate. So we need this idea for the next part. Okay, so when we think of divide, which is here, we don't really divide this when we deal with the complex numbers. We actually just find the conjugate of the denominator. Now, essentially, when I'm dealing with complex numbers and I have an I in the bottom, it's something that we don't keep down there. Like when we have a square root in the bottom, like a 1 over square root of 2, when you guys had trig, or if you had trig. If you didn't, that's okay. Essentially, when I have a square root in the bottom, I can't keep it there. I have to rationalize it. So I multiply the square root of 2 by the top and the bottom. So then I get square root of 2 over 2 as an answer. So I can't have a square root in the bottom. So in a very similar way, I can never have an I in the denominator or in the bottom. So we're going to use the idea of conjugate. So when I look at this problem here, I'm going to take the top and the bottom, and I'm going to multiply it by the conjugate of the bottom. Always of the bottom. If I don't have an I in the bottom, I don't have to do a conjugate. So this is going to end up being 5 plus 12i. So then, if I'm following the laws of algebra, I have to multiply the top by the same thing. Okay, so then what I have to do here is I have to multiply these out. So each of these problems is a problem that we had previously. So they get a little longer here. So for the top, I'm just going to write it out this way so you can see it. I'm just going to multiply 13 times 5 and 13 times 2. And there's the top. So the top is actually going to equal 65 plus 26i. Top is done. The bottom here, we're going to have to do a FOIL again. So first I'm going to do 5 times 5, which is 25. And then 5 times 12, which is plus 60i. And then times here, negative 12 times 5 is going to be negative 60i. And then for the last number here, whoops. And then for the last number here, it's going to be negative 12i times positive 12i. So that's going to be plus 144. Oops. That's a negative I squared. Okay, so that's what the bottom is. Well, it's quite long. I didn't give myself enough room for that, did I? That's okay. I can always move the other one over. So anyways, and remember, I squared is equal to negative 1. Another thing to see here is that I have a positive 60i and a negative 60i, which means together, those are going to give me 0. So I get 65 plus 26i all over 25 minus 144 times negative 1, because I squared is negative 1. And from there, I get 65 plus 26i over, really, 25 plus 144. And that equals 65 plus 26i over 169. And I don't know if you know this or not, but 169 is actually 13 squared. So it's 13 times 13. So one thing I realize is every term on the top and the bottom all have a factor of 13. Now remember, when I'm actually simplifying these, I can't just take the first one and the bottom one by itself. I actually have to take all three of them. And I have to take the same number out of all three in order for it to be legal. So don't violate the law. Thank you. Okay, so anyways, so I see that 13 goes into all three terms. So 13 goes into 65 5 times. 13 goes into 26 2 times. And 13 goes into 169 13 times. So what we end up with is, and I'm going to do 2 steps in one here. Maybe I won't. I'll wait. I actually won't do that. That's a bad idea. Okay, so this is going to be 5 plus 2i over 13. Now this is almost done. It's not completely done yet. We have one more step here. This is really 5 over 13 plus 2 over 13i. And that's the actual final answer, because the form is usually a plus bi. And that's how we're going to have to write it. So get used to that. That's the answer. Okay, now let's do part B. So the conjugate for this one, remember, it's always by the bottom too, not the top, the bottom. Okay, which is the denominator. Okay, so the conjugate of negative 2i is 2i. So I'm going to multiply the top and the bottom by 2i. Now, it's a distributive property here for the top. So that's going to be 4i minus 2i squared. And then on the bottom, we're going to get negative 4i squared. And this equals. Now remember, we can't simplify. Got to clean it all up first. And we know I squareds are equal to negative 1. So this is really 4i minus 2 times negative 1 over negative 4 times negative 1. Now, you don't always have to include this step here, guys, so kind of keep that in mind. You don't need this step, the one I just wrote here. If you skip that on a test, I would be fine with that. But I'm just doing it for the sake of understanding where all of our signs are coming from. So this is going to be 4i plus 2. And then on the bottom, I'm going to get a positive 4. Now, if you notice all three terms again, they all share a factor of 2, which means I can simplify it a little bit more. All right, so this is actually going to be, and I'm going to rewrite it first, because anytime you see a complex number, the real part is first. And then now I'm going to simplify all of my terms here. 2 goes into all three of those. So 2 goes into 2 once, it goes into 4 twice, and it goes into 4 twice. So this is going to turn out to be 1/2. Now I'm skipping that step. Plus 2i, well, 2 over 2i. And notice this, I can simplify more here. Maybe I should have waited. I should have actually separated it first and then did this, because now I have to add another step. Okay, so this is actually going to be 1/2 plus I, because 2 over 2 gives me 1. And 1i is just I. Okay, the last one now. And remember, it's always the denominator. So the conjugate of I is negative I. So I multiply the top times negative I. So on the top, I'm going to get negative I, and on the bottom, I'm going to get negative I squared. So remember, I squared is negative 1. So that means I get negative I over negative 1. So this is going to be negative I over, this is going to turn out to be a positive now, because the opposite of a negative 1 is positive 1, or a negative times a negative is positive. So this is just going to be a 1, which my answer then is negative I. So there's the answers for each of these.